Hey guys, welcome back. Taylor series. This is going to be video 4. We are going to now do cosine x, all right? So once again, to write the Taylor series for cosine x, we are going to take the function cosine x and take many derivatives. F of x is cosine x. The derivative of cosine is negative sine of x. Derivative of negative sine of x is negative cosine of x. Now the third derivative is sine x, and we get back to the original. So I'm going to stop there. We are centered around 0, so we are going to substitute 0. F of 0, cosine of 0 is 1. F prime of 0, sine of 0 is 0. Negative cosine 0, negative 1, 0. F of 0 for the fourth derivative is 1. So we're going to constantly follow this formula. So cosine x is going to be approximately, ready? 1 plus 0 times x to the first over 1 factorial. Remember that c is 0, okay? And remember f prime of 0 is this guy right here. Next, f double prime of 0, let me take away that there, minus 1. X minus 0 squared over 2 factorial plus 0 times x to the third over 3 factorial. And finally, we're going to do one more because we have it here. It's going to be plus x to the fourth over 4 factorial. So what you'll notice here is cosine cleans up nicely to be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial. And they are all even exponents. Do you guys remember in pre-calculus when your teacher said that a cosine function is all even? Remember, it's symmetrical with respect to the y-axis. So a really good approximation for cosine x is this polynomial right over here. All right? So let's go on to the next. I'm going to show you something really cool. Cosine x is what we just learned, all even. Sine x is all odd, okay? This is an equal sign. We've learned throughout our entire life that whatever you do on one side of an equation, as long as you do it on the other side of the equation, it balances each other out. I'm going to take the derivative of sine x, and I'm going to take the derivative of this polynomial on the right side of sine of x. And look what happens. The derivative of sine x is cosine x. The derivative of x, okay, we don't really care about the 1 because 1 factorial is just 1, and the derivative of x is 1. The derivative of x to the third is going to be 3x squared. Remember, 3 factorial is just a constant. It's just 6, all right? So 3 factorial, 3 divided by 6 is just 2. And remember, 2 can be written as 2 factorial. 5x to the fourth would be the next derivative over 5 factorial. Remember, 5 factorial is 5 times 4 times 3 times 2 times 1. The 5's cancel out, and you're left with this. That's 4 factorial. So the greatest thing about all of this is if you know a Taylor series, then you can figure out the derivative of a certain function or even the integral. So like if you, let's get rid of this stuff here. I hope everybody sees it. I think everybody already learned it, but just in case it's the first time you're learning it, if you integrate cosine x and you integrate each one of these, then you are going to get sine x and its approximation. That's beautiful, and it's going to help us in later videos, okay? So I hope everybody gets that. Now, I'm going to finish off with a free response problem that I started with the previous video. So, in the previous video, we found that sine of x was all of the odd functions, and then we created sine of x squared, which I have down here. We said every time we see an x, we're going to put an x squared, and this is what we got. If you forgot it, go back to that video. So this is what we get for sine of x squared. We are now going to finish it off since we now know what cosine of x is with respect to a polynomial, and we're going to just add it. So I put cosine x in red. I know you guys love how I did that. So when I combine it, we know the only way that we can add polynomials or terms is if they have the same exponent, okay? So we need this to be, it says, write the first four non-zero terms of the Taylor series for cosine x, that's this guy, great, and use that series and the series of sine x squared to write the first four non-zero terms of f, which is this guy here. So we want the first four non-zero terms. So we're going to start here. 1 cannot be combined with anything, right? So we're going to be adding this together. 1 can't be combined with anything. So the first term is 1. Great. I'm going to choose a different color. The next, we have an x squared here. And remember, x squared over 2 factorial is the same as x squared over 2. So x squared minus x squared over 2, I just need a common denominator, so that's going to be 2 and 2. And 2x squared minus x squared is going to be x squared over 2. So you just put them together, okay? So once that's taken care of, my next one is going to be x to the fourth. Remember, you got to take the smallest exponent first when you are doing the terms. X to the fourth cannot be combined with anyone, so I'm just going to put them as a standalone. So let me get rid of this stuff here, okay? The next one is going to be x to the sixth, so you guys are going to have to brush up on your mathematics over here. So let me teach you the fast way of how to do this. So negative x to the sixth over 3 factorial minus x to the sixth over 6 factorial. Now obviously 6 factorial is bigger than 3 factorial, but it's bigger than it by 6 times 5 times 4, right? So if I do 6 times 5 times 4 times this entire 3 factorial that I have there, I'll get 6 factorial. So 6 times 5, 30. 30 times 4, 120. So by me changing this guy here to 6 factorial, I would just have to compensate by putting 120 there. So if you owe me 120 and you owe me 1, right, then you owe me 121 x to the sixth over 6 factorial. And that's how you combine that fraction. So I hope that made sense. In order to add fractions, you need the same denominator, and 3 factorial and 6 factorial will meet at 6 factorial. So you have to say, how do I get 3 factorial to become 6 factorial? Well, if you multiply by 6 times 5 times 4, and then multiply the numerator by 6 times 5 times 4 to make sure that you didn't change the value of this, then you're all set. So that's how you do part B. I hope that was helpful. The most important thing, in my opinion, is to realize what you can do now that you have sine and cosine, and by taking derivatives and integral. So come back for the natural log. It's going to be great.